Hi everyone, welcome back. Lastly we learned about the usage of this variational refinement optical flow class, and in this video we are gonna focus to the member functions, the parameters is including. Actually there are 6 parameters we need to check. We can switch to the code part. Here are the parameters. So if we run the code, we are gonna see the default values. Here we see, for example, the 20 is the alpha default value, and for example for the omega is the default value is 1.6. So we can always keep the default value result in the right side. So for example, we can come to a moment. So for example, let's say here. Also we can back again later. So we can always compare the result with the default, so we can understand what these parameters are actually doing. But before starting, just to remind from the previous video also, this class is using the output of any other optical flow class. For this case, we are using PCA flow. You can use others. Just keep in mind the performance of this variational refinement class is up to the base optical flow class, because if this is already a bad result, this already has a bad result, so you cannot expect a perfect performance from this variational refinement. So first of all, you need at least good result from any optical flow class, then you can get you can improve your results with this variational refinement. Just you need to keep this in mind. So we can play with the alpha value first of all. So the alpha default value is 20, and we can play with the result. Actually what this alpha is doing is just maybe if there is any explanation, because in here interestingly they make some even short there are some explanation in here. It says it's about the smoothness, so increasing this, since our result is already a smooth background, so we cannot expect it's gonna really improve the results. But let's say for example if we keep it 100, the default is 20, so we increase it, the expectation is gonna be getting more smooth background or smooth results. Let's see how it's working. And this moment already the default result also not giving any motion vector here. Okay, maybe here also there were many vectors in the default. You can check if you go back in the video. And for example here it doesn't change many things, because I think 20 is enough even, so we don't need to increase the smoothness. But if we decrease my expectation, the smoothness can little get in trouble, so we can get bad results. So at least we can understand what this parameter is doing. For example, for this case the default value is not giving so weird. Okay, there are many maybe noisy motion vectors with the default results, but at least they are not giving weird directions. So in here we see that. Also for this one also there are many wrong direction vectors. Okay, even here. So this is the moment I think which we keep. So you see here at least the motion vectors directions are correct, but here you see it's wrong. So this is controlling the smoothness. Giving small results is gonna decrease the accuracy, giving high results is gonna increase the accuracy, we can say simply. So this is about the alpha value. We can switch to the delta one. So we just need to call the set delta. The default is 5. So if we increase, first of all, let's say 100 again, but let's see what this delta is doing. This is controlling color constancy term. So I also searched about this little bit. If you have a, for example, you have an object, but this object is moving in a colorful background, or there are many colorful passes in between the frames, so maybe you can, in this case you can increase this value. For example, now we're getting 100. We are in somehow giving information to the algorithm. We have a colorful environment, so make the calculations accordingly. But for example, my environment is very smooth, very clean, it's not really colorful. In this case, if you give a high value to these parameters, you see some cases in most scenes we are gonna see it's not working well. Even here, because we already said this is a colorful environment, but it's not working as expected. So just keep in mind, if you have a colorful environment, maybe you can increase this accordingly, but for our case it's not working fine. If we decrease 1, we are saying my environment is already smooth, so you don't need to worry about it. So if we do this, you see my results is very very uh, very similar to the default results, so like that. Okay, this is about the delta. So now we can switch to this iteration part. If you see any iteration parameter, you need to understand increasing this is gonna, most of the time is gonna increase the accuracy, but at the same time you are gonna get slow results. And on the other hand, if you decrease this parameter, it's gonna be fast results, but you are gonna lose accuracy. But yeah, this is a trade-off that we are always talking. The default is 5. Let's try to make it 100. Now the expectation is getting better results. Maybe let's see how it's gonna work. Okay, we can go. We need to check details maybe, but some noisy motion vectors maybe here cancelled. You can check with the others later. Okay, here still there are many noisy motion vectors. Here also I think these are, yeah, nothing is eliminated. Increasing the iteration for our case is not really changing. Okay, I found something. Here you see increase the in here is not found with the default values, but in the left side increasing the iteration, giving one more motion vector, which is correct. Yeah, so this is working in this way. But on the other hand, if you decrease it, my expectation we are gonna get noisy results. Let's see how this work. Okay, maybe here more extra motion vectors, at least I can say, added to here. So yeah, here even maybe we can check. Okay, here already has, there is one more here, here is not. So yeah, we can say, of course, decreasing the iterations also decreasing the accuracy. So this is also done. Now the next is gamma. We can play with that one. Let's see if any explanation in here. Gradient constancy term. I think let's just, I didn't check this well, but we can just simply increase the value and check the result and how it's working. I think, let's say, okay, let's come to a moment. Okay, we already increased the value. The default was about get gamma here one. What was the default? Okay, the default was 10. We made it 100, and it was here. Yeah, so I can say it's getting worse. Let's see this moment also. Okay, increasing this value is decreasing the accuracy. So on the other hand, if we are decreasing it, I think it's gonna give better results on the other hand. Let's see. Okay, at least not worse like before. And see the moment we need to compare. Okay, also it's not really, because I get here not good results. So maybe we cannot directly say directly just increasing is decreasing the accuracy, but maybe you need to find the optimum value in your cases. So this get gamma, maybe you just need to, if you are not sure, just use 10, which is the default one. And this get omega is a little bit interesting. I also searched about this one. Let's try to set it. So when I search, they are suggesting give this value between 1 and 2. If you are if you want to get better results, make it close to the 1, and if you want to decrease the accuracy, maybe you need to get closer to the 2. For example, the default is 1.6, and if we try let's say 5, and we are gonna get weird results because I already tried before. For example, any moment you see there are really many, this is black because it's finding many motion vectors. Most of them is wrong, so it's getting a trouble results. So if we try 2 is gonna, according to my search, it says increasing this is gonna decrease the accuracy. Let's see, for our case at least we cannot say it's really trouble. Maybe this case only, but I don't know what the default value is showing. Okay, it's not affecting. So if we make it 1, how it's gonna change? Let's see, we are gonna get better results or not. Let's try to come to that moment again. Okay, it's not much changing, but as I said, this should be between 1 and 2, so the default is also already 1.6. And the last value was about also the iterations, and this is gonna be similar with these iterations. So the people who are really interested, maybe they can check the details of iterations, but I didn't search about these things well. But all I know is increasing these things is gonna increase the accuracy but decrease the speed. So my method is, if I really need to change these parameters, then experimentally I'm deciding all these parameters. Actually, I don't try to learn the detailed mathematics behind these things. Yeah, experimentally mostly I'm learning, but the simple things is gonna help you much. These iteration things, these trade-offs, accuracy between speed and the accuracy, and these things I think are gonna help you much. I can also suggest find your optimum values according to your experiments. Because computer vision mostly about the experiments. That's what I learned in my career, so I can suggest you that also. Thanks for watching. See you in the next videos.